photon is a bundle of energy with no mass or weight that travels as a wave at the speed of light and moves through space in a straight line. A tube head is a tightly sealed, heavy metal housing that contains an X-ray tube that produces dental X-rays. It includes the step-up transformer, step-down transformer, X-ray tube, metal housing of X-ray tube head, anode, cathode, filament circuit, tube head seal, aluminum discs, position indicating device, lead coulometer, unleaded glass window of X-ray tube, and insulating oil. The X-ray machine is plugged into an electrical outlet, which supplies energy to the machine. When the X-ray machine is turned on, the electrical current flows from the outlet to the control panel via the cord. The current then travels from the control panel to the tube head through electrical wires in the extension arm. This current is directed to the filament circuit and step-down transformer in the tube head. The step-down transformer reduces the 110 or 220 volts entering voltage to around 3 to 5 volts. The filament circuit uses this reduced voltage to heat the tungsten filament in the cathode portion of the X-ray tube. This process is known as thermionic emission. As the filament heats up, electrons are released from the tungsten filament. The outer shell electrons of the tungsten atom acquire enough energy to move away from the filament, creating an electron cloud around the filament. The electrons remain in this cloud until the high voltage circuit is activated. When the exposure button is pressed, the high voltage circuit is turned on. The circuit accelerates the electrons produced at the cathode across the X-ray tube toward the anode. The distance between the cathode and anode is very short, less than half an inch. The electronic focusing cup in the cathode helps direct the electrons toward the tungsten target in the anode. The electrons travel from the cathode to the anode. When the electrons strike the tungsten target, they cause the atoms to release energy in the form of X-ray photons. This process includes two types of radiation, Bremsstrahlung and characteristic radiation. Bremsstrahlung occurs when the high-speed electrons are slowed down or deflected by the positively charged nucleus of the tungsten atoms, releasing energy in the form of X-ray photons. Characteristic radiation happens when an electron collides with and knocks out an inner shell electron from a tungsten atom. This creates a vacancy that is filled by an electron from a higher energy level, releasing energy as X-ray photons. Less than 1% of the energy is converted to X-rays, and the remaining 99% is lost as heat. The heat produced is carried away from the copper stem and absorbed by insulating oil in the tube head, which helps prevent overheating. The X-rays produced are emitted from the target in all directions. However, the leaded glass housing prevents most of the X-rays from escaping the X-ray tube. A small number of X-rays can exit through the unleaded glass window of the tube. These X-rays travel through the unleaded glass window, the tube head seal, and aluminum discs, which filter out longer wavelength X-rays. The lead collimator restricts the size of the X-ray beam. The X-ray beams then travel down the lead-lined position indicating device and exit the tube head through the opening at the end of the position indicating device. Here is a diagram of the dental X-ray tube head with all the parts labeled. Here is the diagram of the X-ray tube with the parts labeled as well.